Hi, welcome to the fun probability problem solving sessions. And today we are working on a pretty interesting problem here. So let's take a look at what this problem is about. So let's say two persons, A and B, are playing a game in which a six-sided die is rolled independently and repeatedly until the first six appears. All right. So if the game stops on an odd number of the time, A win. Otherwise, B win. So first wise, read these problems here. You need to be careful. See here, it doesn't mean like they take a turn to roll the die. Okay, so it's basically said if like that's why they said the die is rolled independently. That means the A and the B was playing the game. I was there rolling the die. So if I got a die, it's 6. If this is on the odd number of the game, then A win. All right. So now let's take a look. Assume the die is fair. What is the probability A will win? If the P denoted the probability of getting a 6 at each row, show that the game always favor A. Well, this is a kind of very interesting part. Why is always favor A? See here. All right, let's go to the whiteboard and let's start to work on this problem here. Like I always said, when I do these problems, I typically like to get, some ideas. Then I can see some examples that I can see what is the pattern. All right, so they said die is rolled independently. So if if the game stop, so game stop is a 6 appear. So I could the game stop at number 1, right? So it's 1-6. So what is here? Then because this is a game number 1, so A will win here, right? So A win. So let's say the probability here of the winning is 1/6 here, right? Okay, now I'm going to throw the die, right? Twice here, okay? And then in order for A to win, it has to stop at the 3s, right? It has to stop at the 3. So that means the first one is what? Is 5/6. And is all the other number is except the 6, right? So it's 5/6. And what is here? So it's 1/6. So this is the game number 3. It's the odd number of the game. So A win again, right? So this is A win. So let's maybe I will put it like this is better. So I will say this is the situation A will win. All right. So what is the probability here? The probability will be 5/6 to the square 1/6. All right. So let's see one more. So if the game stop at the the 5th time, it's right 1, 3, 4, 5, right? Okay, so because the game stopped at the 5th time, so that means what? That means A win again. So the 5th time, that means the previous one has to doesn't have a 6. So it's a 5/6, 5/6, 5/6, and 1/6 here. So the probability here is what? Is 5/6 to the how many? 4th power and 1/6 here, right? So now we can answer the probability of what is the A will win here, right? So A will win will just be you add this one together, right? So you kind of will just be add here, right? So this is 1. Okay, so this is 2. Okay, so be careful. So the probability A will win will just be the 1/6 plus 1/6. And this is the 5/6 to the square plus 1/6 and 5/6 to the what? To the 4th. and da 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 da, and then here you can factor the 1/6 out, so this is 1 plus 5 over 6 to the square plus 5 over 6 to the 4th, and okay, so obviously this is a geometric series, right? So let me write down the formulas here. So if I have a geometric series, it's 1 plus r squared plus r cubed, da 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 da. So the sum here has to be what? 1 minus r, right? R is the ratio. Okay, so in order to use this formula, the first term has to start with 1. So this is perfect, right? So it starts with 1. So the ratio, so what is the ratios here? The ratio is 5 over 6 to the square. That's right. Okay, so then I can use the geometric formula. So what is my answer? So this is to be 1 over 6 times 1 minus r. So it's 1 minus 5, 6 to the square, correct? Okay, so 1 minus, so this is 1 over 6, and so this one's here, 5 over 6 is 25 over 36, so 1 minus it is 36 over what? 11, right? So you flip it and got the 6 over 11. That is what the A will win here. All right. So now for any general probability, so if this die is not even a fair die, that's fine, you know. So here, okay, so this is a probability A will win. So if you read the problem, say otherwise the B will win. So what is the probability B win here? Okay, so B win. So you have either A win or B wins, right? So the B win will just be 1 minus 6 over 11. So it's 5 over 11. See here. Okay, let's take a look at the general cases here, right? So when A is to P, so that means we have the same things here. So we have first one is P's, right? And then the second case, you go to the problem number 3. For the game number 3, so first have 1 minus p to the p. Then you go to the game number 5. So the last one is the occurred. Then you have 1 minus p, 1 minus p, 1 minus p, 1 minus p, right? So now let's take a look at the probability A will win again. All right. So the A will be what? Will be the p plus 1 minus p to the square of the p plus 1 minus p to the 4th of the p and go da 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 da, right? So do the same things. I take the p out. So this is 1 plus 1 minus p to the square plus 1 minus p to the 4th and da 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 da. So this is a geometric series again. So this will be the p times, and from here to here, I know what is my r. R is 1 minus p to the what? To the squares, right? So I can use my geometric series. It's 1 minus r. So it's 1 minus p to the square over 1. So the remaining will just be the algebra. So here you will see here, this is a p, you FOIL it. So it is 1 minus, this is 1 minus 2p plus p squared, correct? Okay, so this will be the p. So this is 1 minus 1 plus 2p minus p squared. And these two you can cancel. Then you have 2p minus 2p squared. You can factor the p out. So this one's here, you can factor the p out. So this is 2 minus p. And boom, boom, the p cancel. Let me get rid of this. So I have enough space. So this is what is 1 over 2 minus p here. All right. So then okay. So that's why. So this is the probability of the A win. So I know the probability of the B win will just be what? Will just be 1 minus 1 over 2 minus p, right? Okay, so 1 minus 2 minus p here. So let's see here. This one here is 2 minus p. So this is 2 minus p minus 1. So this will be the 2 minus p and then 1 minus p. And so I know that's why the p is always bigger, right? Why? Okay, because p, they have the same denominators, right? So in here you can say this one here is definitely less than 1, the 2 minus p. Why? Because the numerator you minus 1s, right? So that's why it's less than here. Or, if you want to, so this is kind of quick, easy ways. Or if you want, you can just take a look. You use the 1 of the 2 minus p minus 1 minus p, the 2 minus p. You use the probability A will win to minus the probability of the B. So it's the same things here. So this is 2. So it's 1 minus P, right? So you will have what? And you will have the P and 2 minus P. And this is always greater than 0. Why? Because P is greater than 0. 2 minus P is greater than 0 because P is between 0 and 1. So that is why it's always favor ace here. Okay, the reason why intuitively you say why the dice rolls independently. The reason why is always favor ace here is because we define the winning. If the winning has to be in the odd number of the times, so it start with 1, right? So start 1, 3, 5. So that's why, because it's always favor the ace here, because the first game you have these chances here. So if let's say hey, if I want if the winnings here, if it's a start at the is the favors is a start at an even number, then it will not be the same stories, right? So if it's even numbers, that means 1, 2, 3, 4. So the first one is a 2, right? So that means if this one's, so you will have a 5, 6, and 1 over 6 here. Then if it's stop at the even number, so this is 1 over 6. So this is 5 over 6, 5 over 6, and 5 over 6. Then it will not favor A anymore because it's the reason why it's favor A is because the first game is here. All right. It's a very interesting problem, and it's not too hard, but it's very interesting and kind of make you think why is favor A here. All right. All right. That's it. Nice talk to you, and good luck with the problems here. Okay. Bye bye.